Good morning, everyone, and thank you for joining us for the final System Engineering Forum event for the 2021 fiscal year. Before we start, we are recording this event, so please keep that in mind. Moving on, I am Alexander Chang, and I'll be starting us off today. I am a senior member of the technical staff at the Aerospace Corporation, serving as the program chair for the System Engineering Forum. I'll be helping to facilitate the event and monitor chat. With me this morning is Alec Gill, who will be supporting us by capturing your thoughts and questions throughout the briefing. We're bringing this to you via our CorpCom team, which is running the production behind the scenes, and it is my pleasure to also introduce Dr. Norman Lau and Dr. Robert Stevens in just a moment. Before that, I'd like to provide a couple of housekeeping remarks. Next slide, please. The System Engineering Forum is a set of virtual events this year, hosted by our Corporate Chief Engineer's Office, and our focus is on model-based system engineering across the space enterprise. So we're looking at how model-based systems engineering contributes to mission success while fulfilling the digital engineering vision. These events have traditionally been held face-to-face between 2016 and 2019, but because of COVID in 2020, we have evolved to provide the virtual format you see today as monthly presentations. We have seen a lot of success and have been able to access a wider audience that would otherwise not have been able to attend. Next slide, please. Once again, this event is being recorded. The recording will be posted on our YouTube site and a link provided to the System Engineering Forum archive page. If you are using Zoom to access this workshop and you are experiencing issues, you can go back to the registration site and there are troubleshooting tips there. Those tips should be posted within the chat window momentarily. These are documents you can download in case you have problems navigating through the Zoom interface. But for the best viewing experience, you may click on the View button at the top of your screen and go into Speaker View. Questions posted in the chat throughout the briefing will be addressed at the end in the order they were posted. Questions may also be asked verbally at the end as well. While the System Engineering Forum generally speaks to how we may apply MBSE for the overall benefit to the space enterprise, today we are looking at how model-based engineering is affecting mission assurance and flight worthiness. Next slide, please. And now it is my pleasure to introduce our hosts today. Norm Lau is the Director of the Acquisition, Risk, and Reliability Engineering Department at the Aerospace Corporation within the Mission Assurance Subdivision, where he provides risk, reliability, and mission assurance application support to national security space and civil space customers. He previously served as project lead for the corporation's integrated mission assurance tool and also oversaw the development and sustainment of the corporate anomalies and launch log database, performing numerous cross-program analyses and studies. Prior to joining Aerospace, he was an instructor for the University of California, Irvine. He earned his bachelor's in math from Northwestern University, his master's in math and operations research from the University of Minnesota, and his PhD in applied math from the University of California, Irvine. Rob Stevens is the director of the Model-Based System Engineering Office at the Aerospace Corporation in El Segundo, California, where he has provided systems engineering analysis support for numerous satellite programs, managed the corporation's Concept Design Center, and served as project systems engineer for several CubeSats in the AirCube program. Prior to joining the Aerospace Corporation, he served as the director of the Small Satellite Program at the U.S. Naval Academy, flew as a naval flight officer in E-2C Hawkeyes, and earned his master's in aeronautical and astronautical engineering from the Naval Postgraduate School and his PhD in astronautical engineering from the Air Force Institute of Technology. With that, I'll pass it to Norm to continue the briefing. Thank you.
All right, thanks, Alex. Yeah, so next slide. Again, this is the outbrief for our model-based mission assurance flight worthiness workshop. I think we already know the participants today. So Rob and I will be the primary hosts. Alec, our recorder, and Alex Chang, who just gave a brief overview, is our overall System Engineering Forum chair. Next slide, please. So today's agenda, we should make it in about an hour. Is just a summary of a workshop that was hosted back on August 17th, and focus was really on helping to understand the scope and nature of model-based mission assurance and flight worthiness. You can see that it was government only by invite and included both civil and DoD customers, as well as Aerospace as the host. The workshop format, and we're going to go into some of the details of the presentations as well as the discussion and findings. We'll have a brief overview for SysML libraries and profiles. That was by Aerospace, followed by model-based system engineering support for airworthiness from Air Force Material Command, NASA's efforts in model-based mission assurance for digital transformation program, and then lastly, SMC and spaceflight worthiness from Space Force. And then lastly, we'll talk about some of the discussion that occurred after the presentations, as well as some of the findings. Next slide, please. All right, I'm gonna let Rob take this first slide, which is the Aerospace presentation.
Okay, hi, this is Rob Stevens, just doing a comm check. Can you hear me okay?
Loud and clear.
Thank you. Apologize, I'm calling from England right now, so I hope I sound clear. Thank you. So we covered in this first topic, Hitav Patel and Myron Hecht briefed us on 3 different topics on activities they're doing at Aerospace Corporation. The first listed there, models for mission assurance. So we heard about reliability and availability and how we can model those in an environment that's digital engineering friendly. It may be used to verify reliability and availability requirements, or mission assurance criteria can be mapped directly to model criteria. And so we were briefed on that, talked about how we could use failure modes and effects analysis and integrate that in with the model as well to factor in things like a mean time between failure, mean time to failure, things like that within a model. Second, we learned about assuring the digital engineering process and how some of the activities are being used in the Aerospace Corporation to do this. And a couple of things are listed there in sub-bullets. We learned how mission assurance activities can be stereotyped, risk management can be stereotyped as well. These are model elements that you might not find in a textbook on SysML or anything like that, but we found that there's no limit to the types of elements, system elements that you can model in a descriptive model, like one that is used in SysML, the systems modeling language. You can create any element you want, and you can relate them in any way you want. You just have to define them up front in the form of an ontology. And so that was one of the things that was described here. Also, workflows. We can model mission assurance workflows. If you wanted to establish dependencies, for instance, on different activities in a project, you can do that, and these can be used to inform planning. The third bullet there talks about assuring the models. So Myron pointed out that not just systems need verification and validation, but the models that describe the systems also need V&V. And so he described a process that we can use and tools that we can use to actually do that. Some of these model verification and validation activities require a human. Think of it like an editor of a magazine or something. You need a human to kind of take a look at the content and make sure the content's correct. But there's some things that can be automated, things like syntax. Think of this like your Microsoft Word spell checker or grammar checker, how that can automatically go through. You don't need a human to do that. So he was clear in how they distinguish the differences there and how you can use automation to do that second piece there. So that's kind of a summary of what we learned in the first topic, and I'll turn it over to Norm to talk about the next one.
Okay, we go to the next slide, please. So our next presenter was Mr. Keith Siders from Air Force Material Command, and he talked on 3 main areas relating to airworthiness certification, and this is part of the Air Force's digital campaign. Initially, he sort of described the Air Force vision to have digital certifications and really reimagining that process in terms of what attributes and elements were critical to that process, and noted that some of the common areas across all airworthiness criteria, such as NIL Handbook 516C, that there were 3 basic attributes, namely design attributes, parametric or testable attributes, and process attributes as part of the digital certification process. Those first 2 attributes, namely design and parametric, can be addressable by system models, and then the last one via process models. This actually then led to definitions of how these objects and data needs would be needed to support modeling of these various attributes. and that's captured in an acquisition sustainment data package, or ASDP. And that's really the digital data package for design development, verification and validation, production, maintenance, sustainment, operation, and modification of a flight vehicle really throughout that life cycle. The final topic that he spoke on was how you take these ASDP and how those data objects can be used and related and implemented not as a set of rule books, but really as a modeling SysML profile. More of the details of Keith's charts are provided, as Alex mentioned, in the archive section of the SEF site. All right, next slide, and I'm going to turn it back over to Rob to describe NASA's presentation.
Okay, so you should be seeing the third topic there, model-based mission assurance in the context of NASA's digital transformation. So this was a talk given by Tony DeVenti from NASA headquarters, and also supported by Steve Cornford from NASA JPL. And they talked about how they are doing digital transformation at NASA. Very informative there. What they discussed was an example shown there in the picture, if you can see it, is showing a kind of an analogy of how, remember the days when we used to have to break out a paper map to find our location. It wasn't that long ago, but it seems that way with all the technology we have now. But I recall the days that these maps were easy to unfold, never fold the same way again. But then we learned to digitize them, and so we transformed into a digital picture of maps. If you recall MapQuest, how you could go online and print out a digital map on a piece of paper, take it with you where you needed to go, plot your routes and things like that. But then we transformed into a more GPS-enabled system where we have actual live GPS updates. Not only that, but we can connect the navigation to traffic and commercial. And so not only can you choose your best route on the fly, but you can avoid traffic. You can find your In-N-Out burger on the way, on your route, things like that, things that we couldn't do before. So that's an example or an analogy for how digital transformation is viewed at NASA. The second bullet there talks about the NASA Data Foundation, FAIR and FAIREST. Those are acronyms that they use. I thought this was one of the key takeaways from the brief, because it talks, I think of these as maybe a set of loose requirements for model and data requirements. So I'll briefly describe what they stand for, because it does apply to some of the things we'll be talking about in the discussion portion. So data and models need to be findable. Data must be discoverable by those who need it. So this could be in the form of a web-enabled application or something similar like that. Accessible. Systems engineers and stakeholders need to be able to retrieve or view the data in a way that's useful to them. This means, we all agree that this, well, what this does not mean is that we don't need everyone to be familiar with digital, or we should say descriptive tools like Cameo or Sparks. Not everyone needs to be an expert in those tools to view and navigate models, but they do need to access the data that's in them. Interoperable. The data needs to be used by different users, different tools, possibly even in different formats. It's not like the Microsoft model where pretty much anyone can open a PDF with different tools, or anyone can open a Word doc using various tools. We may not achieve that, and it may not even be desirable to achieve that. We need to be flexible and interoperable enough that we can change data in various formats. Reusable. The tools and models should be general enough so that they have a broad application and can be reused. And I'll even add to that, it wasn't explicitly stated, but they need to be usable in the first place in order for them to be reused. I think some of that's captured in some of these other bullets, but that's a key one there, is they need to be reusable. Understandable is for the U there. Data formats are readable. We need them to be readable by humans. Remember that we don't just have models for models' sake. They need to be read, understood, and communicated between human beings. So that's an important feature of this. Secure, not only to protect proprietary and classified information, that's obviously important, but also to maintain accessibility and integrity of the data as well. And then finally, the T is for trustworthy. So we need authoritative sources of truth. They require curated data and data management. So again, think of those as kind of the requirements for your models in your digital environment. So they also describe briefly in bullet 3 there what model-based anything is. So a lot of these kind of spread across the board. I know it's probably hard to see that graphic there, but they spread across to other model-based activities. But the focus here was on model-based mission assurance. And with that, I'll turn it over to Norm again.
Thanks, Rob. We go to the next slide. And then our final speaker is Mr. Jay Landis from SMC, now known as SSC, or Space Systems Command. And he spoke about the SMC's spaceflight worthiness criteria, which is a process used to certify missions before they actually launch. That covers primarily spacecraft and ground systems, and it's governed by two documents as identified there. There's an SMC guide and then a technical operating report that describes the specific criteria and how they're met. It's worth mentioning that the Space Launch NSSL, they use a slightly different approach, but it's similar to actually certify their spaceflight worthiness criteria. Now, the criteria is actually a self-assessment by program offices with assistance from the Enterprise Core Engineering Group, and performed at flight readiness review, and intended really to be a life cycle process from all the way from acquisition to launch. So the promise of implementing digital engineering is that we can really, instead of being document-based, really utilize some of these system engineering processes throughout life cycle. Now, digital engineering is already somewhat in use to satisfy spaceflight worthiness criteria, for example, on the requirements management side, the use of DOORS tools. But as SMC or SSC moves more into an integrated digital environment, we want to also look at how model-based approaches could also benefit. And there are some early pathfinders that are currently underway, really focused on looking at the governance documents and developing workflows that can be appropriately modeled. So still somewhat in the earlier phases, but also very much of great interest to this customer. All right, next slide. All right, so now we transition to what was the discussion portion, where we had opened it up to not just the presenters, but other government attendees. And there were really 5 goals that we had hoped to try to cover. First one was, how do we define model-based mission assurance flight worthiness? Second is, what does it actually mean to say something is model-based? Specifically, what is MA to be? What does it mean to be model-based? Third one was, what are some of the goals and benefits of a model-based mission assurance flight worthiness approach? A fourth one was to identify really some of the challenges, opportunities, but also challenges to how MBSE or model-based practice could be implemented. And then the last one, which we didn't have as much time to get to, but what are some potential pathfinders that might be worth pursuing? So next slide. I'll talk to the first one, and that is, how do we define model-based mission assurance flight worthiness? For the space community, we already have a pretty well known definition for mission assurance, at least across national security space, and then similarly for flight worthiness across Air Force and Navy. So we had some interesting discussions about how do we actually define model-based mission assurance. You can see in the bold text, those are some of the key highlights. We sort of captured a lot of the discussion, but integration, that we have integrated models, not only of the descriptive, but also the analytical models. Descriptive being those typically modeled in an MBSE tool. We did talk about that there needs to be not only a structured aspect to model-based MA, but also traceability, that you need to understand where the pedigree of the data, of the models, and sort of what Rob just described as part of the NASA Ferris approach is what's the provenance, or what is the trustworthiness of the data that you're getting. NASA actually indicated that they have a standard 7009, where it's a standard for how you validate simulations and models, and which covers both descriptive analytical models as well. We also had a side discussion about, well, is model-based mission assurance a subset of MBSE? The agreement is it's more of a subset of model-based engineering, but we had various views. There probably wasn't really a consensus in terms of what is the hierarchy or ontology of where MA fits within the realm of model-based everything. But we did come away with sort of a proposed definition. We consider this a working definition, and the takeaway there, again, focusing on integration. It's really the disciplined integration of analytical and descriptive models to manage risk, quality, and safety throughout the system lifecycle. Depending on your viewpoint, risk and quality and safety, they're pretty common across various customer sets. You might expand mission assurance in particular to include other disciplines, but these were sort of the core ones from a mission assurance and flight worthiness perspective that we thought needed to be captured. All right, so that was the first one. Move to the next slide, and I'll let Rob take this one.
Okay, so you should be on slide 10, showing the discussion topic 2. So this picks up where Norm just left off on the model-based mission assurance proposed definition. And we asked the question, what does it mean to be model-based? We wanted to poke at that a little bit more. We all agree that the models are trusted sources in a model-based system versus documents, but what else does that mean? So that's where some of the sub-bullets there you see under the primer questions. One thing that came up again and again was connectivity and integration, meaning that the models, the data were not stovepiped, they were able to be accessed and connected and integrated with other tools and data sets. The connectivity can represent different things. In other words, we mentioned a couple different enclaves that different groups of folks that would be using the data, for instance, government and contractor would be an example of different enclaves of data that would need to be shared. How much, the level of connectivity, how much modeling and connectedness do we need? That was a question that came up a couple times. Connectivity doesn't have to mean connect everything all the time. So we all understood that the different data sets, the different models that are used can operate independently just fine by themselves. In fact, a lot of them are heritage models and tools that have been doing this for years. And so, it's not like we are changing that independence, but also they could be connected when needed to connect into the greater data sets. There was a Pathfinder example that was mentioned in Keith Sider's briefing in the Air Force from Air Force Lifecycle Management. He mentioned the Mill Handbook 516C for airworthiness, which presents some airworthiness certificate or certification criteria rather for aerial manned and unmanned systems. But it was basically guidance and not mandated, but it was more guidance, not requirements. Kind of like if you're familiar with the Mission Assurance Baseline, the MAB that we use for some of the space systems, similar to that provides guidelines. So what the Pathfinder was to see how we can modelize that, or how we can take some of those safety critical functions, create elements out of those, and then create a profile from that. So that's a good example of a Pathfinder for trying to take an existing guidance handbook to modelize it. Configuration and data management. So understanding where the data is coming from is an important thing. I mentioned data curation before. If you remember from the Ferris model that NASA was using, trustworthy was the key part of that. And so that's a key part of that. And lastly there, under the first primer question was a counterexample. NASA mentioned a counterexample of Sapphire, which is a reliability tool that works fine by itself, but it doesn't connect to anything. It requires lots of human interaction, hand jamming of data back and forth between different things. So it's definitely not model-based. So that obviously presents problems when you're trying to integrate it with other tools and systems. Second question we asked of the people in the conference were mission assurance and flight worthiness guidelines and instructions. Do they have any reference documents and how to modelize them? I mentioned one of them, the Mill Handbook. And again, that was a really good example showing how you can take model criteria that relate to other subsystems like V&V activities, which are themselves related to requirements and hardware and software. And this way you can observe how the criteria set forth in those reference documents impact the entire system from a mission assurance or flight worthiness perspective. But there are a couple other documents mentioned. One was the draft SSC, formerly known as SMC, MBSE style guide, which addresses making models consistent. And Norm just mentioned one on the previous chart, the NASA Standard 7009, which is NASA's approach to developing and verifying model requirements, not just SML models, but all types of models. So with that, I will turn it over to myself. If you switch over to the chart, I think I'm talking about this one too. So we should be on chart 11, discussion topic number 3.
Yep.
And so this was identifying goals and benefits of model-based mission assurance and flight worthiness. So we listed quite a few. Some of them are similar to what you would find in model-based systems engineering benefits, but there are a couple others listed here. So some of the ones that we came up with in the working group, quality, everyone was expecting better systems through improved systems engineering rigor and other benefits that I'll go to here in a minute. Speed through automation. I mentioned verification a couple times before. One of the nice things about linking V&V activities in a descriptive model is you can observe some real-time changes to requirements and activities, or real-time verification of those requirements if they're linked properly, and you have some parametrics kind of describing the relationships between tests, analysis, demonstrations, inspections, things like that, to requirements activities. You can get earlier metrics to analyze. Modeling forces early conversations. When you get a group together of systems engineering stakeholders to model early on in the life cycle, it forces those early conversations, especially as they relate to mission assurance and flight worthiness, that may not otherwise have happened or have been addressed in any other way if you had not done that. So it helps identify some of those pitfalls early. Handling increased complexity. So you can add more and more elements in a descriptive model. It's not really limited by the number of elements, as long as you have people that are connecting the elements together and showing how they relate to each other. There's no real limit to that. So it does help handle increased complexity. It does require us to form an ontology to describe those relationships between the elements, but that's kind of the key part of it too. Enhanced rigor, I mentioned that before. This is how we can unambiguously define system structure, system behavior. Things like behavior would be things like maybe if you're talking about a spacecraft system, it could be modes of operation for power or attitude control or fault logic, things like that. You can also unambiguously define requirements and how those relate to mission assurance related criteria and how those criteria impact those requirements. Explicitly incorporating lessons learned. So one thing that came up is we have lessons learned after every project or development. Then we want to, instead of just kind of capturing those in a document somewhere that may or may not be seen later, we can take those lessons learned. For instance, let's say we get a new procedure or we have a modified procedure that we want to include in that. We can bake that right into the model itself. And then that way, if you're reusing the model for the next system, then those procedures and new activities are baked right in there. So that's a convenient way to incorporate lessons learned and make them actionable instead of just something that collects dust. Traceability, not talking only about requirements, that's an obvious one, is tracing requirements down to lower level requirements and things, but also with an ontology map, you can trace, again, any element to any other element. You can trace a mission assurance criteria that may be outlined in one of those guidelines or reference documents that I mentioned a minute ago. And you can relate those to V&V activities and relate those to system elements and requirements. And you can even relate those to risks and mitigation. So that again, there's no limit to the different types of things that you can trace to. Government reference to compare with contractor products. This is a mechanism you can think of this as an example, maybe it's a mechanism to import contractor products. And if you want to have the government evaluate those contractor products using a government reference model, that can be done through something like this. Cost is a big one, that last bullet there. And these may be direct cost reduction measures. One is larger investment up front during the required requirements developments may pay off later, and that's what we are intending to do. But during INT, when time and cost are a premium, that's not the time to make changes. So that's why it helps to model these things up front, and that's one way to improve cost. Helps avoid pitfalls. Another way is just time saving during milestone reviews and preparation. Things like you want your engineers spending more time designing and building and less time prepping PowerPoints. So one nice thing about a model that exists and is an authoritative source that's capturing things in real time and it's not static, dynamically changing with updates, is that you can just take a snapshot at any given time to the different views that you want to show stakeholders and use those as your reviews material instead of having to have the engineers generate these every time. with that, I will turn over to Norm again for the discussion topic 4.
Thanks, Rob. So our fourth question had to do with what are some of the opportunities and barriers to incorporating model-based mission assurance. And we tried to summarize kind of some of the key points here. So the subtopics or sub-questions had to do with what obstacles might there be to implementing change, what are unique barriers for model-based practice, and what are some factors that could assist in incorporation, kind of overcome those challenges. So you can see the 2 columns, we have identified barriers and then some potential solutions. By no means are these the end-all be-all, but just some initial ideas. The first one has to do with connectivity and integration. So imagine we have physically dispersed locations, for example, government and contractor may not be co-located, and we may even have within government multiple locations. You also have potential classification of data at various levels, and also intellectual property, contractor intellectual property. So kind of combining a few ideas here, not just the connectivity and integration, but also managing of proprietary IP, for example. Some potential solutions, of course, there are cloud-based, could be on-prem or off-prem to address different locations. I think some vendors, MBSE vendors, are already starting to implement some of those kinds of solutions in terms of various security mechanisms, the ability to store IP on a controlled server, and potentially using that approach for controlling IP as well for different data levels. I'm sure different enclaves will have to be part of that solution. The next one had to do with cost, like Rob had mentioned on the previous slide. There is a not insignificant investment cost to both adopting MBSE as well as if I want to use some of those approaches for performing mission assurance or flight worthiness. Well, question naturally is what kind of ROI will I get, return on investment? Some initial ideas, of course, start off small. Don't try to take on the elephant at once, using potentially internal research and development funding or corporate funding, really just develop some of those core capabilities. I think we also wanted to look at how might we develop metrics to measure success. And I think that's going to be a ongoing hot topic. How do I know that my investments are going to pay off? So that's certainly a barrier. Next one, the third one, it was a very well recognized, and that is how to overcome cultural inertia. That is, there's a resistance or some existing approaches, whether it's for systems engineering or mission assurance. Why should I change? If it ain't broke, why fix it? So there's a few approaches. I think NASA had a really great chart. I don't have a copy of it, but this has been a known problem, that is resistance to change for, I'm sure, hundreds, if not thousands of years. So in terms of different approaches from the bottoms up, this one was, I think, a great idea, really promoting MBSE as a service. And the example here is, instead of having people necessarily learn SysML or have to interact with a MBSE tool, meet folks where they are, be able to generate artifacts such as reliability artifacts, FMICAs, and whatnot, in a form that the analysts recognize or they understand. And goes back to what Rob said earlier, we don't need everybody to know how to program in SysML, but the models, the descriptive and analytical models, should be able to provide artifacts that the engineers and analysts are used to seeing and can help perform their job. And it's just a different venue using MBSE to make the generation more efficient. From a top-down perspective, of course, it helps to have leadership support, the senior stakeholders. Part of that might be the government owning the technical baseline. And there's definitely training and awareness is going to be a big part of overcoming the inertia. I think, just going back to Rob's example, or it's actually NASA's example, going from map makers, I'm sure there was a great resistance when you go from paper maps to digital to kind of that future. But we have to be able to again, provide some of that training. What is MBSE? What are some of the benefits? And DAU and other, NASA has a great learning site as well. Be able to provide some of that training. And help understand what are the benefits of going model-based. The next one was an interesting point is perceived risk is that programs, if they spend too long in design phase, well, then the potential of risk of being canceled increases. So that's interesting because one of the values of model-based mission assurance or MBSE in general is that if you have a good design phase, as in the case on the right, you may uncover problems that may not surface until you get to INT. So by having, when you have complex systems, it is too easy to make a change in one area and not realize the ripple effect. But using model-based approaches, we have the opportunity to actually uncover some of those changes. So this is an interesting, I don't think we have an exact solution, but being able to identify potential problems and ultimately reducing your down the line schedule definitely has a net positive benefit. The next one has to do with difficulty of sharing models across the span of stakeholders. This goes back a little bit to what I said earlier, which is we don't necessarily need everybody to be able to understand or read SysML diagrams, but we do need to have the span stakeholders, not just the modelers, but systems engineers as well, be able to share models and share information, more importantly. And you can see on the right, really understanding who are my end users, whether they're actually interacting with a model or interacting with those artifacts. I need to understand what their needs are. And again, going back to the NASA's fairest approach, we thought it was a nice foundational way to think about, well, not just models, but also data. What are some of the attributes that we need to recognize that all users, all stakeholders need to be able to make good use of that information. Talked a little bit about using, there is a lack of government reference models, specifically the descriptive models. Obviously, seems kind of glib, but start to develop some of these government reference architecture models. And then lastly, the lack of standards. We know there are standards in our handbooks for how we perform mission assurance, but how do we do that in a model-based approach? So the development of those standards is definitely needed, not just for automation purposes, but also to get consistency when we put out requirements for contractors. Okay, next slide. And then the last question that we had for the group was, and this is where we sort of ran out of time, but what would be some potential collaborations and pathfinders? I won't read through the table, but you can see a few ideas. I will identify at the bottom, we had, I think Rob had mentioned Mill Handbook 516C. SSC or Space Systems Command has currently an MBSE style guide in work, and also mentioned that NASA has a standard 7009 governing validation, verification, and more of various models. So these are some potential areas of ongoing collaboration. If there's anything in particular, I think, yeah, I don't think there's any one thing that stood out in the Pathfinders, but these are some different ideas that the group came up with. So yeah, so that's that slide. Okay, if we can move on to the next. All right, so this is just a wrap up. Again, we came up with a definition of model-based mission assurance and flight worthiness. We touched on what does it mean for those practices to be model-based. We also identified some of the goals and benefits, and as well as some of the challenges. And then lastly, we did come up with a few potential collaborations. One thing that wasn't mentioned earlier is NASA is actually working on auto creation of a safety emission assurance plan from a model. And so that seemed like a great use of a tool. Going back to the idea of being able to generate an artifact that folks need to be able to interact with, and instead of having to interact with a model, the model can actually be the source of truth and generate something like a MA plan. And we talked a little bit about Keith Siders and the efforts at AFMC to develop this model-based certification process. And so I think there are some opportunities there for other government to learn. And we do want to, in future interactions, this was a government-only workshop, but we do want to start to begin to collaborate with contractors and industry as well. So that is I believe that's the last chart. And so we can sort of open it up, I guess, to questions.
Hi, Norm. So starting from the top, a Ronald Cole asked, "Is there a space, a space worthiness SWFCs from other government agencies, e.g., NASA, FAA, etc.? If yes, are they consistent? If not, would or are these other government agencies use the DoD product?"
So I think the one I can speak to is Air Force Material Command, which Rob briefed the intro slide. There are several. If I go back to, I think it's Mill Handbook 516C. There are a few. This is specifically for airworthiness, so they don't use the same certification processes. And the question was, is there an opportunity for to leverage it? Can you read the second part of the question again, Alex?
If not, would these other government agencies use the DoD product?
Yeah, well, so there's two cases where you have two DoD entities, SMC and Air Force Material Command. I think by nature of the systems that we're talking about, space, where systems cannot be serviced versus aircraft where they can, certification processes are naturally going to be very different because I may put on maintenance and operations requirements on aircraft that I can't possibly put on spacecraft. So I don't see, for example, Air Force Material Command adopting the SMC's spaceflight worthiness criteria. But if any, and by the way, so I think we have some of our presenters from NASA or Air Force Material Command, and maybe even SSC. We can have them chime in as well, if it's possible.
If they do chime in, I guess I'll leave it to the chat for now. Moving on, a Martin Feather asked, to what level of detail is software behavior modeled as part of the larger system model in which that software plays a role?
I think it depends on which system we're talking about. Rob, do you have any thought? I know you've done some system modeling.
Yeah, I can talk to that a little bit. Just in regard to modeling in general, not just software, but anything, the level of modeling you need. I know this is kind of a circular way to think of it, but it's really not. And that is, you model until your questions are answered. So if you have questions that require the need to get, and hopefully I'm understanding the question correctly. It's a little garbled on my side, but you model to the level that it answers your questions. If your questions are related to how specific software is performing, or you need that level of detail to answer questions, then absolutely. But you don't need to overmodel it either, if that makes sense. You don't need to overmodel all your systems and software, hardware, down to the nth level of detail, if that's going beyond the questions that you have. Hopefully that answered the question. I heard that right.
I believe the attendees are also unmuted. So if any of these questions you need can provide clarification on, you're also more than welcome to as well. Okay, then moving on from a Richard Desland, they were hoping they might be able to see a model, perhaps examples. Is that something that might be possible among the guest presentations, guest presenters, or ourselves in regards to model-based mission assurance examples?
I don't think we can speak on behalf of our presenters, but Richard, I think you work at Aerospace, so you definitely can reach out to Rob or myself, and we can see about providing you some information.
Great, thank you. And then the next from Samantha Infel. What are the types of elements in MBMA libraries? What are the different ways risks are connected to other MBMA elements?
I can talk to that a little bit. Some of the examples that I explained from Myron Hecht and Hitav Patel, some of the MBMA elements I mentioned are risk, and you can create risk elements just like you would in any other context with a consequence and a likelihood. In fact, those can be different parameters of each of the risks, just like you would do in a risk assessment matrix or something. But you can link those to other elements like mitigation. Perhaps there's a mission assurance criteria or something that addresses that risk, that type of risk specifically, or maybe that risk could be related to a requirement. You know, you could create a stereotype for instead of just call it an allocate relationship, you can say a has risk relationship. These are the types of stereotypes that I think Hitav and Myron were talking about. So those are various elements that you can connect in with your broader model. Hopefully that in part answers that question, if I heard that one right.
In addition to that, Hitav is online, and so he answered a little bit as well, so I'll just repeat it here. In particular, in particular, some of the aerospace team has modeled risks, mitigation plans, verification activities as custom elements in our descriptive SysML models. These are tagged with fields that are common with JIRA due to the nature of some of our projects that we were pathfinding. We also have FMEA as parametric diagrams. These elements can have assigned associations attached to requirements, blocks, activities, and most other elements in the SysML model.
And that brings up another point that Hitav just made. It just reminded me. He mentioned JIRA. That just highlights the fact that these tools and models should be integratable with other tools and models. JIRA is a different tool that's good at doing tracking and of issues and things like that. JIRA Confluence, and it can be integrated or made integratable into a SysML model. So that's a good point that Hitav made.
Okay, moving on. Paul Calhoun is curious to know what AF-LCMC's position is on how complex a government reference model they provide to contractors during program development. That is, how much importance they place in providing something like a UAF model of the required capabilities, vision, etc., and having the contractor extend that in a system model traced to the government-provided architecture.
Yeah, so unless Keith Siders or somebody from AFMC is online, I don't know that we can address that in detail. But if Paul reaches out to us, maybe we can put him in touch with Keith.
Something I can add is that in general, I'm not entirely sure of AFLC MC's position, but there was a general consensus that a passing of a model was a potential route in which they can connect models together from the government as related to the contractor side. So there's this, and then there was a discussion on how that might come about, whether the model on the government side does identify those capabilities, visions, etc., and then having the contractor extend that was one potential option. Another option, and then there were a few other options that I can't remember at the moment, but that was a pretty decent portion of the conversation when that came about, because that does help to, at least in the mission assurance space, bring back some of the traces from the contractors over to the government, which was not always clear in when models weren't, not when, but since models weren't being used.
Hey, this is Steve Cornford. Someone was asking about examples. I have a little 2-minute video I could show that sort of ties in some other stuff if you think that'd be appropriate in the short amount of time we have left. We just finished, I guess, to Samantha, maybe I'll just say the words. And to Samantha, we just finished a project we've been working on where there's a thing called an assurance case, safety case in England. And there's also a NASA standard 8729.1 where they've taken reliability and maintainability and folded it, into that. So we have modeled that and tied in a Cameo plugin from Titronics to do fault modeling. So we've got a few examples we could show. This might not be the exact right venue. Unless you guys want to see that little video. Have you seen the Cameo Sim toolkit as it executes state machines and fault stuff? Was that part of Myron's talk?
I don't think it was part of Myron's talk, but yeah, we have seen
I mean,
it.
I assume he's taking advantage out of it because it's very powerful and it allows you to do, we call it fault injection, where, when you're doing risk management, you got a likelihood and a consequence. And often, and I'm belittling a little bit, often we're wagging our thumbs in the direction of consequence. And it's very powerful to be able to run a con ops, inject a fault, and then see what came out. So there's no more thumb wagging about the criticality of a risk. So I think there's a lot of promise from these integrated simulations. And I'm really interested in following up with Myron on some of his work too.
Thanks, Steve. Alex,
Thank you.
Question?
Yeah, there are a few more questions, but I just also wanted to point out that Tony DeVenti in the chat also provided two other NASA procedural requirements that are currently being used for flight worthiness to address an earlier question on the kind of proliferation of certification of worthiness. In NASA's case, they use NPR 8705.4 for human-rated missions and NPR 7900 for air vehicles. And then elements, NPR 8705.2, not 0.4. And elements of these documents do leverage various FAA certifications and do adhere to ranges of safety requirements. So there's a bit of tailoring, as Norm kind of mentioned earlier, that there will necessarily be tailoring of these documents for their specific uses and domains. But there are some, at the very least, some loose references to each other. Perhaps those references aren't as identified within the overall community, but at least within our own documentation, there's some references there. Thank you. And moving on to the next question. Let me see. So Hatav is already kind of addressing that question, but Nigel Shaw asked, do you consider the changes in SysML v2 will help in the in this problem space, assuming the mission, the model-based mission assurance problem space? And then additionally, have you considered the challenges of ensuring the many different models that will be used are consistent, especially when designs are changing fast in the early life cycle stages?
This is Steve Cornford. I can give one quick response to that. When JPL was doing Europa, and we had a large integrated team modeling, there's some rules that are obvious, and there's some other ones that people have to decide on. But as they used to tell people, when they put the code to bed at night, they got 40,000 automatic processes running, checking, and gathering information for review and management. So it's going to be complicated, but turns out machines are pretty good, pretty smart, and they're pretty fast too.
Okay, thank you. Let me see. So another question from Mark Baldwin. There was an article in the June 2021 Getting It Right newsletter that featured a model created for the AeroCube project. Is it possible to get a demo of that model?
Actually, it looks like Hatav has in the chat responded to Mark.
Yes. His response is, we have created detailed state machine and activity diagrams in some of our projects that have connections to other elements and blocks in SysML models. These diagrams map out, oh, I'm sorry, this is to a previous question to perhaps the software portion. His
I can
response.
address the AirQ10 one a little bit.
Sorry. Yeah, go ahead.
The AirQ10. Yeah, that model was a very detailed model, because the questions that we were asking our model to answer related to AirQ10 were down to the level of fault modes, fault tolerance, and so modes of operation were a very key part of that model, because those were the questions we had. So yes, they had state machines that were down at the circuit board level, so a very detailed model. And in answer to Mark's question, is that accessible, or is that something that you can view? Robbie Kellogg is a good resource for that. He developed most of that model. Over.
Great.
Yeah,
thank you.
this is a Tav. Also, we just for procedural, and we just have to make sure that we're going through our own release process to make sure there's no IP or controlled information. So it takes a while for demos to come out, but yeah, if there's interest, we could definitely showcase that in a future iteration. And we could reach out to Robbie, who's also on our MBMA team.
Great, thank you. Hatav, while I have you on the line, your presentation focused a lot on the profiles and the libraries that might be used on top of potential SysML models. Are those profiles available to the public, or are there any descriptions of those that are available to the public?
Right. So I just noted that, agreeing with after Stephen's comment. So, Myron, who's also my co-presenter and also a colleague here in the MBME team, he's one of the teams, along with our software assurance subject matter experts, that are trying to put together some plugins for SysML VMV, automated SysML VMV, and trying to get that eventually, again, through our process distributed, but also trying to mature that for later this fiscal year, or sorry, next fiscal year. So that's going to be, that's our plan going forward as well.
Great, thank you. And if anyone is interested, I guess I implore you to reach out to Hatav or Myron. Perhaps a method of informing the attendees when that might be available. On that note, Ronald Cole was also asking, can the links to other items and the email IDs for the speakers be sent out to the attendees in case we have future questions? I guess for those of us online, if you might be able to confirm your emails in the chat. And then for those who were not able to attend, at least speakers, we'll confirm whether they'd like to release their emails or not. And then, let's see, moving on to, I believe, Kalyani Rengarajan's question: VMV and t-test the actual software on the actual hardware. How could we use the models and digital twins in the closure of requirements?
Okay, this is Rob. If I heard the question right, is how can we use digital twins to help support requirements, if I understood that correctly. So a digital twin is, by nature of being a twin, needs a physical twin. And so the idea of a physical or digital twin, physical twin pair would be that there's interaction between the two. The digital twin represents the physical twin. The physical twin itself can provide data in the form of, if it's a satellite, for instance, it can form data in the form of telemetry or housekeeping or some type of data back to the model that can improve the model, which then better represents the system and so forth. So it's kind of this cyclic type of feedback loop. So how does it support requirements? I would say that if you're developing a system that is part of a product line, and you each one of the digital twins is going to be a unique instance of the system, that physical twin system that it's representing, but the form of the digital twin is going to be the same. A lot of the types of information that is going to be the same between the two. So I would say that using a digital twin to do analysis on a system as you're developing requirements, you can kind of verify some of the requirements anyway during the early phases. Using a digital twin, I guess at that phase it would be mostly as a simulation type of thing. If you wanted to verify, attitude slew rates or power consumption or whatever it is that you're trying to do, you can use a digital twin to do that early analysis part. And then as the system develops and you kind of get more into integration and test, and you actually have physical components, and that physical twin starts to solidify a bit, then you can again update your digital twin and use that to further refine by analysis or verify by analysis your different requirements using the digital twin. Hopefully that helped to answer at least part of that question.
So Rob, this is Kelly. So I do understand that you can use the digital twin and the models more in the analysis phase early on, but in terms of closing the requirements at the end for integration and test and validation, verification test of the system, not of the model, there are requirements that we run on actual software and actual hardware. So I'm wondering if there are missions that have used the concept of digital twin and models to close requirements at that stage, at the end, not in the beginning analysis stage. Over.
Yes, I think you can. I think if I'm understanding, you're saying in the later life cycle phases, maybe during integration and test, when you actually have physical pieces of hardware, can you include those in the loop too, and verify using your digital twin the various components? Is that kind of what you're poking at?
No, the argument I got was for VV&T, validation, verification, and testing of systems, they are required to close the requirements. And when you do that with the digital twin, they cannot close that because it has to be on the actual hardware. So there was an argument that the digital twin and the model-based system concept doesn't help a whole lot in that area. So I'm trying to find counter arguments to that. I'm trying to find out how, if and how the digital twin concept and the model-based system engineering can help in that activity. Over.
Yeah, that's a good question, Callie. I think I'm going to have to process that one a little more. And I apologize, my connection's kind of bad, so it's hard to hear everything everyone's saying. But if I understand the question, it's digital twin doesn't have any obvious, or at least people are saying that doesn't have any obvious help in the later life cycle phases in terms of requirements. So I think I'm going to have to process that one a little bit and get back to you on that.
And so that we can, it is at a little bit past the top of the hour. So there's been a lot of conversation, and we'll try to, if you want to continue conversation, we'll leave this line open a little bit longer between each other. Or if you'd like to contact each other, please provide each other your emails so that you can continue on. But I believe we should at least provide the opportunity to close out for those who may want to head out. So Sarah, I believe if we can move to the final slide, thank you. So thank you, Norm, Rob, our hosts for the workshop. For those who are in the participation, our presenters during the workshop, and our CorpCom for bringing this all together. Immediately after this event, all the attendees will receive a quick 6-question survey. So please let us know how we did. Any feedback is absolutely appreciated. Requests for future kind of demonstrations or content will always be appreciated, as it will help guide us to understand what content really needs to be focused on. This is particularly true as this is our last event of the fiscal year. So as we're trying to build up the itinerary or the list for next year, please, any feedback is definitely appreciated so we can give you the quality briefings. And with that, thank you for attending. That concludes our model-based mission assurance and flight worthiness out briefing. Wish everyone a wonderful day. And as mentioned, we'll stay online for a little while longer for those who may want to trade information or trade additional comments. But thank you.